Warm welcome to everyone. This is Sekar, statistician from Department of Accounting. Let's today talk about chi-square test. Shall we move? So before going to chi-square, we want to know the basic concepts of statistics, which is the scales of measurements. Basically the scales of measurements is four types, which is nominal, ordinal, ratio, and interval. Okay, in nominal, it is based on category. For an example, gender, male and female. Okay, and the next one is ordinal. Uh, Nominal and ordinal is both are category, but the one minimal difference in ordinal, the order imposed on category, it is called as ordinal. So it is none other called than qualitative data. It is describe the quality of the particular attribute. Okay, next one is both the ratio and the interval comes under quantitative variables. It will be measured in either fractions and decimal points. This is scales of measurements. The major type is qualitative and quantitative. Okay, in quantitative, it is a continuous and discrete variable. Okay, and then in qualitative, the nominal and ordinal variable. The example for ordinal is some order imposed on category. Here, if you want to know the DHS status, it will be categorized into mild, moderate, and severe. Okay, education level, mild and if you want to know the pain scale, how the pain is for the patient, like mild, moderate, and severe. Some order imposed on the ordinal. It is called ordinal. Before going to choosing the statistical sets, we want to know what are the scales of measurement, how they are measured, and then how many groups in that scale, and then the groups are independent or paired or matched. Okay, selection the test, the assumptions of the test must be not to be violated. Each test have some assumption to the statistical test. First, we have to focus on assumptions. If once the assumptions are violated, we cannot run the statistical test. And then based on the scales of measurements and a proof of data, there is a variety of testers available here. If it is a nominal variable, between the two groups, if it is independent, we can choose with the chi-square test. Nominal data, it is independent, we are going to chi-square, which means it is not related to each other. If it is repeated measures, for an example, if you want to know the depression score scales among winter and summer, it is the same person you are mentioning the winter and summer depression rate. So it is a repeated. So here we can use a McNemer chi-square test. Okay, for two groups. If it is three group or more than three groups, we can use chi-square test or Pogrund's Q test. If it is ordinal data for independent two group, we can go with the Mann-Whitney U test. If it is repeated measures, which means paired differences, we can go with the Wilcoxon signed rank test. Okay, if it is more than three group, we can go with the, if it is independent, we can go with Crystal-Wallace H test. If it is repeated, Friedman ANOVA will be used. Or quantitative variables, like if it is independent, we can go with, there is a two type of t-test, which is paired and unpaired. If it is an independent variable, we can use unpaired t-test. Okay, that is called z-test or t-test, independent t-test. If it is repeated measures, if we want to know if we want to assess the effectiveness of new drug on the same patient before and after it is a repeated, so we can use a t-test for assess the effectiveness. It is a repeated measures. If it is three group, we can go with ANOVA. Okay, analysis of variance. If it is a repeated measures of ANOVA. If three group with the repeated measures, we can go with the repeated measures of ANOVA. This is how we have to choose the statistical test based on scales as well as uh, type of group, and then two group or three group. Okay, next. So which test to be applied for that? It's based on the outcome measure. If it is a two related group, if it is outcome measure is proportion, we can use McNamara test. As well as we said, for an example, you want to know the depression among the candidates in winter and summer. If it is measured in proportion, we can use McNamara test. If it is mean, if the outcome variable is mean, we can use paired t-test or Wilcoxon sign test. It is based on the normality. If it is normal distribution, we can use paired t-test, or it is non-normal distribution, we can use Wilcoxon rank t-test. Okay. If the group are two independent groups and the outcome variable is proportion. Okay. Now we can use a chi-square test. For an example, if you want to know is there any association between smoking and coronary heart disease? They are independent, but the outcome variable is proportion. We can use a chi-square test. If it is a continuous variable like mean variable, we can use unpaired t-test. Okay. Is there any association between two groups? So we can use unpaired t-test or non-weighting test. If it is a normal distribution, we can use unpaired t-test. If it is a non-normal distribution, we can use non-weighting test. If it is a more than related two groups, if it is proportion, we can use covariance Q test. If it is mean, we can use ANOVA test or Friedman test. If it is more than two groups, we can, if the outcome variable is proportion, we also use chi-square test for those. If it is mean, ANOVA test or Kruskal Wallis test. Okay. So coming to the topic. So what is chi-square test first? Okay. The chi-square test is symbolically represented chi-square. It is none other called chi-square and chi-square. The data should be categorical. So the nominal and ordinal data will be used only for this chi-square, not the interval and ratio scale. If it is an interval and ratio scale, we have to make them into category, and then we can do a chi-square test. Okay. So it's a non-parametric test to use the association between two categorical variables. Okay. This is mainly used for chi-square test to find any association between two dichotomous variables. The most important rule, the expected value, not observed value, of each cell must be at least 5 for the test to be valid. It is one of the assumptions for doing a chi-square test. The given data is our observed test. The expected value will be calculated. The expected value less than 5, we can go with Yates correction. Yates correction. Okay. So, what is chi-square test? The chi-square test is statistical method used to analyze categorical data to determine there is any significant association between two or more group or variables. For an example, if you want to know is there any association between obesity and coronary heart disease. So we can use a chi-square test if um, the data is categorized, we can use a chi-square test. So what are the steps involved in chi-square test? First, we have to formulate the hypothesis. Okay. Later we will see the what is hypothesis. Let's we see that step 1, step 2. And then step 2, we have to form a 2x2 contingency table. Okay. If the researcher the examiner give the scenario, we have to make a 2x2 contingency table. It is a very, very important step in chi-square test. If you are doing any mistake in that 2x2 table, the whole sum will be wrong. Okay. If the 2x2 contingency table is right, if for 99%, your problem will be right on. In step 3, we have to find the expected value. Okay, the expected value will be calculated from the observed values. The formula for expected value is row total into column total divided by grand total. Okay, in a 2 cross 2 table, there is a row total and column total divided by grand total. It will appear the expected value for each cell. You have to find the expected value for each cell. The cells are A, B, C, and D. You have to find a 4 expected value, and there is a 4 observed values. Okay. Step 4, you have to substitute the values into chi-square formula. The chi-square is equal to summation of observed value minus expected value, the whole square divided by expected value. This is our chi-square test statistic formula. Don't forget, chi-square is equal to summation of observed value minus expected value, the whole square divided by expected value. Already we know the observed value. We have to find the expected value from the observed value and then divided by expected value. So is the combination of a degree of freedom with the table value and calculator chi-square value. They depend on the table value. For finding a table value, we have to know the degree of freedom of that given data. Okay. For chi-square degree of freedom, the formula is row column minus 1 into row minus 1. How many columns in that row? If it is a 2 cross 2, that is a 2 column. 2 minus 1 into 2 minus 1. The answer will be 1. So here the degree of freedom is 1. Okay. Compare the probability table. For the 1 degree of freedom, the probability table value is 3.841 for chi-square value. Mostly for medical, they will give a 2 cross 2 table. So your degree of freedom and probability value, the degree of freedom will be 1 and the probability value is 3.841 for 2 cross 2 table. It will not change at all. So you don't worry about the degree of freedom and probability value. Once you know the degree of freedom formula and probability value, it will be very easy in the step 6 to compare the probability value with the table value and calculated chi-square value. Okay, so first we have there is a 6 step. First step is you have to find a hypothesis and then form a 2 cross 2 table. Mostly the examiner will give a scenario. You have to construct a 2 cross 2 contingency table. It is very, very important step in that chi-square step. And then expected value, the formula for finding expected value for row total into column total divided by grand total. This is the formula for expected value. And then chi-square formula. Chi-square is equal to sum of observed value minus expected value, the whole square divided by expected value. And then finding a degree of freedom. So it is row minus 1 into column minus 1. Okay. 2 rows and 2 columns. So answer will be 1. So compare the probability value. It is 1 degree of freedom, which is 3.841. Don't forget it is 3.841 for 1 degree of freedom. If it is a 5% of, it is for 5% significant level. If the researcher want to know the 1% of significant level, the probability value will change. Okay. Here, how to form a 2 cross 2 table. Here, always here the risk present, disease present. Okay, and disease absent. The disease will be on the top. Disease present and disease absent. Here, the test or risk, either test or risk factor present or absent. Okay, this is a cell A, B, C, and D. Okay, and then the total A plus B, C plus D, A plus C, B plus D, and this is a grand total. This is a row total, and this is a column total. For finding a cell, So expected value for A cell here, for A cell, the row total is A plus B divided by, sorry, row total into column total, right? So A plus B into A plus C divided by A plus B plus C plus D. This is for A cell. So let's see one problem. They are giving urban and rural area distribution of anemia. Here, we want to know what is the risk factors and what is the disease. Here, the urban and rural are our risk factors. Here, urban and rural, and our disease is anemia. Anemic present, anemic absent. This is our disease. So anemic, non-anemic, non-anemic, and urban and rural. Okay. Here, 1,000 persons were surveyed in a research study of which 50 belongs to urban and other 50 belongs to the rural area. So overall, 100 members are enrolled for a survey. So the grand total will be 100 and the urban and rural 50-50. 50 belongs to urban and other belongs to rural area. So 50 belongs to urban, 50 belongs to rural. Okay. And then among the total population surveyed, 60 individuals were screened to be anemic. So here is anemic. Okay. Here 60 will be here. So, so overall 100 members in that 50 belongs to rural, 50 belongs to this is urban, rural, present, and anemic absent. Okay. 50 belongs to urban, 50 belongs to rural. In that, in the total population, 60 were anemic. So A plus C is 60. 60 numbers were anemic. Okay. In that, 20 were residing in the urban area. 60 individual were screened to be anemic, of which 20 residing in urban area apply the suitable statistical test. So here 20 will be residing in urban. So here we have to subtract. So here it is 40. So 50 minus 20 is 30. here it is 10, here it is 40. This is how we have to make a contingency table like this. Okay, are you clear? This is based on the scenario, anemic absent and anemic present, and here the risk factors are the test is urban and rural. Overall, urban urban population is 50 and the rural population is 50. Overall grand total is 100. In that 100, 50, 60 were anemic. Okay, 60 were anemic. In that 20 residing in urban. So 60 total anemic patient. In that 20 is urban area. The remaining part is from the rural area. So here we have to subtract all these things. We get a proper 2+2 contingency table. This is how we have to make a 2×2 contingency table from the given scenario. Okay. And then first step, you have to make a hypothesis. So what is, before going to hypothesis, what is type of hypothesis? What is hypothesis here? It is a tentative testable statement about relationship between two or more attributes or variable. It's a tentative testable statement about the relationship between two or more attributes. It is a statement before the research is done. Okay. The hypothesis is tentative or postulated idea before the research started. Okay. You want to either you can prove or disprove through the statistical test. If it is apply all the assumption, we can go with the chi-square test. If it is follows the other assumption, we can do a other test. Okay. Okay. Now we can see what is null. There is a two type of hypothesis. First one is null hypothesis, and another one is alternate hypothesis. Okay, here null hypothesis is denoted as, the hypothesis is generally denoted as H. Okay, H hypothesis is denoted as H. Here the null hypothesis is denoted as null is denoted as H, H0 or H0, which means there is nothing. H0 missing, there is nothing. There is no difference in the distribution of anemic between urban and rural area. There is a two type of hypothesis. First one is null hypothesis. Null means zero. There is no difference in the distribution of anemic between urban and rural area. It is based on the given scenario. They are giving a anemic status comparison with urban and rural. If it is any other scenario, it will change. Okay. The null hypothesis, there is basically any type of scenario, it will start from there is no difference in the distribution of anemic between urban and rural area, or there is no association between anemic and urban and rural. In the alternate hypothesis, it is denoted as H1. 1 means dichotomous yes. So, which is yes, there is something in that statement, which is that there is a difference in the distribution of anemic between urban and rural areas. Okay, this is the two hypothesis which is formed by given in the scenario. First hypothesis is a tentative idea before the research is done, which is we want to test using chi-square or some other test. Okay, and then null hypothesis, there is no difference in the distribution of anemic between urban and rural areas. That is null hypothesis H0. And the Other one is alternate hypothesis. There is a difference in the distribution of anemic between urban and rural areas. Okay. Already we see, right, formation of two class two table here. So already we discussed the scenario. Overall, 100 samples, 100 population were surveyed. In that 100, 50 belong to urban, 50 belong to rural. Okay. In in the total, 60 were anemic. 60 were anemic. 20 were residing in urban. Okay. Overall, 60 anemic patients. In that, 20 were residing in urban area. So automatically, the remaining 40 will be residing in rural areas. Okay. They are in scenario, they will not give a whole data. We have to make them into a cluster table. They will give a either if it is a 4 cells now, they will give a 2 or 3 data only. We have subtract from that data. Overall 150 from urban, 50 from rural. In that 100, 60 anemic patients, and then in that 60 urban, 20 were urban area residents. Okay, remaining 40 will be the rural area residents in presence of anemic. Okay, and then already we know in urban area totally 50 members, and in that 20 were already in anemic. So remaining 30 will be anemic free. So no anemic patients. In the rural area, 50 were already, anemic patients. So in the 10 is a non-anemic patients. Okay, are you clear about this statement? Let's say give a question. 100% was surveyed in a research. Here I make a table. So 100 is a grand total. Okay, this is urban, this is rural, anemic percent, anemic absent. So 100% were surveyed in a research. Study to following 50 were belong to urban and each 52 and other 50 belongs to rural area. So here 50, here 50. Okay. Among the total population surveyed, 60 individuals were screened to be anemic. So anemic total, both urban and rural is 60, which 20 were residing in the urban area. In urban area, 20 were residing in urban area. So remaining 60 minus 20, 40, 50 minus 20, 30, 40 minus, 50 minus 40 is 10. So it is 40. This is how we have to make a 2x2 contingency table. Are we clear about how to make a 2x2 contingency table? Shall we know? So the second step is formation of 2x2 table. As well as I told, the next step is you have to find the expected value for each cell. Okay. Here, row total into column total divided by grand total is the formula for finding expected value for A. Here, let's draw that table. 40, 20, 30, 50, 50, 40, and 60. Okay, it is A, B, C, and D. We want the expected value for A. The row total will be 50 into column total will be 60 divided by grand total 100. This is the expected value for A cell, and the expected value for B is expected cell for row total is T, and the column total is here the B cell is column total is 40, not a 60. Okay. For A cell it is column total 60. For B cell it is 40. 40 divided by 100. Okay. For C cell, the row total is 50. The column total is 60. 60 into 50 divided by 100. For a D cell, 50 into 40 divided by 100. Are you clear about the expected values? The expected values. So expected value for A cell 60, 60 into 50 divided by 100 is 30. For B cell it is 20. For C cell it is 30. Again the C cell it is 20. Okay, this is how we have to make a expected value from the observed values. Okay, it is a given values 20, 40, 60, 30, 10, 40, 50, 50, 100 is the observed value. The red color marks is the expected value from the observed values. Okay, this is for A, this is B, C, and D. Okay, next step we have to find a chi-square value for both observed and expected value. Okay, so as well as we said, okay, so for observed values minus expected value, the whole square divided by expected value, where the expected value is here, it is 20. These are observed values, and the expected value is 30. So for the A cell, observed is 20, expected is 30. So summation of observed value minus expected value, the whole square by expected value. Okay, this is for A cell, this is for B cell, this is for C cell, this is for D cell. Okay, I'll highlight here. This is chi-square for A plus chi-square for B cell, and this is chi-square for C cell, and this is chi-square for D cell. Are you clear? Okay. The observed value for cell is 20 were residing in urban, which is anemic. 20 minus 30 divided whole square divided by expected value for each uh, A cell and plus the B cell, the observed value is 30 minus 20 the whole square by 20 plus 40 minus 30 the whole square by 20, and then here it is 30, not 20. Here it is 30 because the expected value is 30. So it is 30 only. For D cell, 10 minus 20 the whole square divided by 20. If you do this calculation, it will come 3.334 chi-square for A and 5 for chi-square value for B, C, and D respectively. And the total chi-square value is 18.33. So overall chi-square value is 18.33. Okay. Find out the degree of freedom, which will be. So already we know the degree of freedom formula, that is the column minus 1 into row minus 1. Here we have a 2 rows and 2 columns. 2 minus 1 into 2 minus 1, which is 1. Okay. Already we said compare the probability table value. It is a whole table is given, but for the exam purpose, I will take it only the significant level for 0.5 and 1 degree of freedom. Okay. On offering a chi-square value table with 1 degree of freedom and chi-square value for probability of 0.05 is 3.841. It is constant. It not change. When it is changed, if it is 2 cross 2 degree of freedom, then only it will change. Or if you want to know the uh, probability value for 0.01, it will change. Otherwise, if it is 5% of the significant level, it won't change. So, you know the two values here. One is observed chi-square values, and the comment is based on calculator value versus table value. Okay, calculated values 18.33 is our calculator value, which is very higher than the table value, which is 3.841. If the table value is less than the calculated value, we can conclude that alternate hypothesis is true, that rejecting the null hypothesis. If it is more than the table calculated value is more than the table value, we have to reject the null hypothesis, which means there is a difference in the distribution of anemic between urban and rural area. We can say it like this. If the 3.841 is less than the calculated value 18.333, we can reject the null hypothesis, which state that there is a difference in the distribution of anemic between urban and rural areas. Okay, are we clear about how to make it comment this? We have a calculated value versus table value. We know calculated value is 18.33 is more than the table value, that is 3.84. In this scenario, we are going to reject reject the null hypothesis. So we can state that there is a difference in the distribution of anemic between urban and rural area. This is how we have to make an interpretation using statistical test. Are you clear about the chi-square test? Okay, let's see another example. In a village, 23 subject developed cholera out of 160% who had taken vaccine of cholera, while 34 other person developed cholera out of 185 unvaccinated subject. Is the difference of incidence of cholera among vaccinated and unvaccinated subject are statistically significant? The researcher want to know the vaccinated and unvaccinated subject are statistically significant for incident cholera. Okay, here we can use a chi-square test. Why? Because the disease is cholera absent or present. The respector or test is vaccinated and unvaccinated. So state the hypothesis for this scenario. There is no difference in incidence of cholera among vaccinated and unvaccinated subject. The scenario is different here. So there is no difference in incidence of cholera among vaccinated and unvaccinated subject. In alternate hypothesis, yes, there is a difference in the incidence of cholera among vaccinated and unvaccinated subjects. Okay. And then formation of progress to table. So here let's do a formation of table. Here the disease is cholera. Cholera present or cholera absent, vaccinated, unvaccinated. Okay. In the village, developed the college 165 take a vaccine. So vaccine group, there is a 160 members in vaccinated group. That is a 160% who are taken vaccine of cholera. They are already taken 160 members who are taken cholera vaccine. In that, 23 subject developed cholera. In the total 160, 23 subject developed with cholera. 23. Okay, here the minus term is 137. 137. Okay, another while 34 other persons developed cholera out of unvaccinated subject. So overall 180 unvaccinated subjects are there. Okay, 160% who are taken a vaccine. Here 180 unvaccinated subject. Here the unvaccinated subject is 180. In that 180, 34 persons developed cholera. 34 were developed cholera. Remaining 146. The grand total will be 340. Here it is 57 is to 83. This is how we have to make a two-cluster table here based on the given scenario. Are you clear about how to make a two-cluster table? So 23 subjects developed cholera out of 160% who are take a vaccine from cholera. Here 23 members are developed cholera out of who taking vaccine. Okay. While other 34% developed cholera out of 180 unvaccinated subjects. Unvaccinated subject is 180. In that 180, 34 persons are developed cholera. The remaining the subtraction will get a 2 plus 2 contingency table. This is a 2 plus 2 table. 2 plus 2 contingency table. If you did any mistake in this table, the total sum will be wrong. Okay. Mostly if you done a good contingency table or proper correct contingency table, the whole sum will be right on. Okay. Next, the hypothesis already we discussed. And then formation of 2 plus 2 contingency table. So already we discussed 180 members were vaccinated. In that 23 were developed cholera. And then 180 subject. In that 180 subject, in that 180 non-vaccinated subject, 34 persons are developed with cholera. Okay, are it clear? And then next step, we want to find the expected value for each cell. For finding an expected value, the row total into column total divided by grand total. Okay, let's cut off this one. This is A. This is B, C, and D. Okay. For finding an expected value for A cell, this row total is 160 into column total 57 divided by grand total 340. Row total and column total. For expected for P, that is B, for row total is 160 into column total is 283 divided by 340. The expected cell for C is 180 is our row total into 57 divided by 340 and expected for T is 180 into 283 divided by 340. Nothing, it's just a cross multiplication. Okay. For row total into column total, for T cell, this row total 160, the column total will be 283 divided by grand total. It is how we have to find the expected value. Are we clear about this? I'll move another. So this is a expected values for each cell. For A cell, 57 into 160 over 340, 26.8 to 133.17. It is 30.17. This is 149.82. So the expected cell will be in and around 1 5 or 10. Okay. Let's put a chi-square values. The observed values is 23 and the expected value is 26.82, the whole square over 26.82 for P. This is chi-square for, this was chi-square for A, this is B cell, this is C cell, and this is B cell. Okay. The summation is coming, add all these chi-square values. The chi-square value here, it is summation of all chi-square values 1.22. Okay. For finding chi-square values 1.22, and we have to find a degree of freedom here. We already know for a 2 cross 2 contingency table, the 2 cross 2 contingency table, the degree of freedom will be 1. Just 2 rows and 2 columns, right? So the degree of freedom will be 1. We already know for 1 degree of freedom, 5% is all of significant. The table value for chi-square is 3.841. Already we see in last example also. So based on the comment, the observed value is 1.22. It is calculated chi-square value is 1.22, lower than the table value. Here, the calculated value is 1.22 is less than the, it is less than the calculated table value, that is 3.841. Okay. This is a chi-square value, calculated chi-square value. This is table value. Okay. The chi-square value is less than the table value. We are going to accept the null hypothesis. We can conclude that the null hypothesis is true, which means we are accepting the null hypothesis. So we are accept that yes, there is no difference between incidence of cholera among vaccinated and unvaccinated subjects. Okay, if it is, it shows that the vaccinated and cholera, vaccination and cholera is independent. There is no association between cholera and vaccination. It is independent. Okay. Since the observed value is 1.22 lower than the table value, we conclude that the null hypothesis is true. The null hypothesis is there is no difference in incidence of cholera among vaccinated and unvaccinated subjects. Okay, so we are accepting that null hypothesis, which means there is no, the vaccination and cholera is independent. There is no association between vaccination and cholera. Okay. I think hope you all understand all this concept behind the chi-square test. First step, we have to find a hypothesis. We have to form a hypothesis. Hypothesis is a formal tentative statement before the researcher want to know is there any association between uh, X factor and Y factor, outcome and factor. And then in that hypothesis, there is a uh, two type of hypothesis, which one is null hypothesis and another one is alternate hypothesis. So the null hypothesis means H naught. Now, nothing is there, which shows that There is no difference, or there is no association between smoking and coronary heart disease, for example. There is no association between smoking and coronary heart disease. Smoking and coronary heart disease are independent. There is no association, which is indicate in that H article. In alternate hypothesis, H1, yes, there is something is there. So it states that there is a strong association between smoking and coronary heart disease. The hypothesis will either accept or reject using a statistical test. It is any type of statistical test. Here we are using chi-square test. Based on the assumption, we are using here chi-square test. If the assumptions are met, then only we can able to do a statistical test. Okay. Another next step is you have to find a 2 cross 2 contingency table. It is very important step in that in cross sectional study, um, and then chi-square, every type of study. It is very important step in doing a 2 cross 2 contingency table. Once if you are if you are making a correct right 2 cross 2 contingency table, the whole problem will be right only. If you made any values or misplaced, then the whole sum is wrong. Okay, and then you have to find the expected value from the observed values. For finding an expected value, we need a observed values, which is already given by the scenario. You have to make a two cluster table. In that, for finding an expected value, the formula is row total into column total divided by grand total. Okay, for each cell, you have to find a expected value. It is nothing but it is a cross multiplication of row total and column total divided by grand total. Okay, and then you have to use a chi-square formula. Chi-square formula is chi-square is equal to summation of observed values minus expected value the whole square divided by expected value. Okay, you have to find the chi-square for each cell. For A, B, C, and you have to find the chi-square value of each cell, and then you have to sum it, and then you have a whole chi-square value. Okay, next step, you have to find the degree of freedom. Okay, degree of freedom mostly for a 2 cross 2 contingency table, it is 1 degree of freedom because 2 rows and 2 columns, 2 minus 1 into 2 minus 1 will be 1. For a 1 degree of freedom, but 5% level of significant, the probability value is 3.841. It cannot be changed. Okay, and then based on the chi-square value, calculated chi-square value and table value, we are going to make a interpretation, comment about the given scenario. Okay, if it is observed values more than the table value, null hypothesis rejected. If the observed values less than the table value, null hypothesis accepted. Okay, I hope you all understood this concept. Thank you so much. Thank you for your time. Thank you.